technologies. Today we'll be talking a little bit about enabling faster construction with modern construction chemicals. To tell you more about that, I'm here. I'm Sunny Surlakar. I'm a civil engineer and a concrete technologist by profession. I've been working a lot in the field of construction chemicals and just want to give you a window into who we are, what we do, and the kind of wonderful solutions that we can do to enable faster construction. So the agenda that we're going to be following today is we'll just briefly introduce our industry to you, talk to you a little bit about why we are relevant and what needs to be done, a little bit about the conditions that are today and what special kind of needs come out of the construction industry, and then pretty much what solutions, or that will be the bulk of what we talk about, is what solutions we can provide. And last but not least, we will conclude the session. So, to give you an introduction to our industry, we are actually a very uniquely placed industry whereby we are a wing of specialty chemicals. So, we basically take the knowledge from the chemical industry and we know how to apply it to the construction industry. That means what chemicals are compatible with, say, for example, the traditional construction materials like be it stone, be it aggregates, be it sand, cement, and so on. So, we work a lot on the compatibility and we find the right solutions to make construction much better. What we're looking to do is basically improve the durability and the sustainability of structures. Among our expertise is three basic, or rather, we can split our industry into three basic expertise lines. The first one is concrete enhancement. That means we generate materials and we generate solutions on how to make concrete better in every possible way, how to improve its durability, how to improve its strength, how to improve its flow, whether we can make self-compacting concrete or we can make self-curing concrete, underwater concrete, waterproof concrete, and you name it. Like any kind of special properties that we need to impart to concrete can only be done by proper construction chemicals. Now, in case your concrete is not made or placed or cured in a proper way, it will show deterioration. And we also have solutions for that, which come through with concrete repair systems. So we can pretty much restore concrete back to its original condition or structures back to its original condition from whatever it is. And last but not least, once both these welcome, ladies and gentlemen, to this session on construction chemicals as well as emerging technologies. Today, we'll be talking a little bit about enabling faster construction with modern construction chemicals. To tell you more about that, I'm here. I'm Sunny Surlakar. I'm a civil engineer and a concrete technologist by profession. I've been working a lot in the field of construction chemicals and just want to give you a window into who we are, what we do, and the kind of wonderful solutions that we can do to enable faster construction. So the agenda that we're going to be following today is we'll just briefly introduce our industry to you, talk to you a little bit about why we are relevant and what needs to be done, a little bit about the conditions that are today and what special kind of needs come out of the construction industry, and then pretty much what solutions, or that will be the bulk of what we talk about, is what solutions we can provide. And last but not least, we will conclude the session. So, to give you an introduction to our industry, we are actually a very uniquely placed industry whereby we are a wing of specialty chemicals. So, we basically take the knowledge from the chemical industry
of the project
and
towards
we know how
its
to apply
completion.
it to the construction industry. That
This
means what
ability keeps
chemicals
coming
are
down
compatible
as
with,
one go towards
say, for example, the
completion.
traditional construction
The
materials
maximum
like be
potential
it
for
stone, be it
controlling the
aggregates,
cost
be it sand,
is there in the beginning
cement, and so
and
on.
starts
So,
diminishing
we work a lot
over
on the
time.
compatibility and we
So there
find
is
the right
all the more
solutions to make
incentive for us
construction much
to
better.
take all the
What we're looking
precautions
to do is
right in the
basically
beginning
improve the
to
durability and
be
the
able to
sustainability
control
of
the
structures.
time and cost
Among
for
our
the concerned
expertise
project.
is three basic, or rather, we
If you
can
look at the
split our
various
industry into three
factors
basic
which govern a
expertise
particular
lines.
project,
The first one is
the
concrete
functionality, of
enhancement.
course,
That
is the
means
most important
we
one.
generate
Then the
materials
bidding
and we
process,
generate solutions
the
on
design
how to make
engineering,
concrete better
the
in every
actual
possible
construction
way,
method,
how to
the
improve its
materials to be
durability,
used,
how to improve its
the
strength,
plant and machinery to be
how to
used,
improve its
and
flow,
finally the
whether we
project
can make
management
self-compacting
to
concrete.
put together
Welcome,
the
ladies and
project
gentlemen,
with all
to this
these
session
ingredients.
on construction chemicals as well as
We
emerging
need to have an
technologies.
approach towards
Today, we'll
integrating all
be
these
talking a
factors
little bit about
with
enabling
the
faster
accent on
construction
the
with
life
modern
cycle
construction
approach,
chemicals. To
and
tell
then
you more
having
about that,
overall
welcome, ladies and
innovativeness
gentlemen,
to get the
to this
maximum possible
session on
efficiency.
construction chemicals as well as emerging
If you look at the
technologies.
various
Today,
ingredients
we'll be
for
talking a little
successful
bit about
projects,
enabling
typically
faster construction with
starting
modern
from the
construction
upfront
chemicals.
clearances
To tell you more
and
about
using
that,
the
I'm
right
here.
kind of design and
I'm Sunny
construction method,
Surlakar. I'm a
which are
civil
properly
engineer and a
integrated
concrete
along with the
technologist
right
by
kind of
profession.
materials,
I've been working a
having
lot in the
adequate
field of construction
resources,
chemicals, and
and
just
getting
want ladies
ensured
and
of the
gentlemen know
funds
the
availability
total we are
at all the
and we
times,
also have solutions for
having a
that,
good project management
which
approach,
come
good
through with
process
concrete
management,
repair systems. So
and
the
above
agenda
all, a good
we'll be
project
following
manager
today is
put
to
together all
briefly
these
introduce
ingredients
our new
and
stream
realize
and
the project
talk a little bit
successfully.
systems why we are relevant. So
In this
finally, to
process, we
protection
need to
system, a
realize
little bit about the
that
generation
design
and
and
help today in
construction method have to be
what special
kept
kind of
hand in
needs come
hand
out of the construction
if one wants
industry,
to realize
and then
good
pretty much
efficiency.
what solutions or that
For
will be the
example, for
bulk
the
of what we
metro
talk about is
projects,
what solutions we can
superstructure
provide.
being
And
done in
last but
many
not
cities
least, we will
today, the
conclude
precast
the session.
segmental construction
So to give
method
you an
is
introduction
very
to our
appropriate
industry,
in
we
that
are
it
actually a
has the
very
least
uniquely placed
disturbance to the
industry whereby we are
traffic, which is
a wing of specialty chemicals. So we basically take the knowledge from the chemical industry, and we know how to apply it to the construction industry. That means what chemicals are compatible with, say, for example, the traditional construction materials like be it stone, be it aggregates, be it sand, cement, and so on. So we work a lot on the compatibility and we find the right solutions to make construction much better. What we're looking to do is basically improve the durability and the sustainability of structures. Among our expertise is three basic, or rather, we can split our industry into three basic expertise lines. The first one is concrete enhancement. That means we generate materials and we generate solutions on how to make concrete better in every possible way, how to improve its durability, how to improve its strength, how to improve its flow, whether we can make self-compacting concrete or we can make self-curing concrete, underwater concrete, waterproof concrete, and you name it. Like any kind of special properties that we need to impart to concrete can only be done by proper construction chemicals. Now, in case your concrete is not made or placed or cured in a proper way, it will show deterioration. And we also have solutions for that, which come through with concrete repair systems. So we can pretty much restore concrete back to its original condition or structures back to its original condition from whatever it is. And last but not least, once both these things are done, concrete enhancement and repair, we have solutions that will protect your structure or your investment in the long run. So this can prevent things like abrasion, the weather, pollution, and those kind of things, and just enhances basically the life of your structure. A little bit on how our industry is very, very relevant to the construction industry. We have been actually helping the construction industry since, I would say, from the time we started in somewhere about 30s, mid 30s, to almost when we came into our own around the mid 60s and the early 70s. From that point on, we have always helped the durability of construction. That means we know how to improve the properties of the materials used and how to make it better. And that, of course, has led to much longer lasting structures in general. Because of the high durability, automatically the structures become much more sustainable because we invest a lot less resources into maintaining and repairing them in the long run. Of course, a lot of the solutions that we manufacture also provide speed to construction, as well as it makes using a lot of the construction materials very easy, like say fast plastering, waterproofing, easy placing of concrete, pumpable concrete, for example. So we have pretty much redefined ease of use in the construction chemical industry. And of course, a lot of things go right simply because we can provide the solutions for construction. So construction can become much more efficient, much more economical. Of course, it becomes stronger and more durable with better mechanical and durability properties. It looks better for a long time. The safety is improved, of course, because the structures themselves last much longer. And then we can also work in different areas such as providing energy conservation, increasing the lifespan of the buildings, and so on. So in short, our industry is one that adds value to any sort of construction. So we are the quintessential masalas in the recipe of good quality construction. That is how we can put it forward. So the situation as it stands today, like what does construction really need? If you talk about construction in India, it's a mature industry. It's big. It provides employment to a lot of people. It's a major part of our GDP. It's a growing industry. It has been, I mean, for a very, very long period of time, but it is still very, very dependent on labor. So skilled labor, of course, remains a problem in the industry, but of course, we are also working a lot in scaling and trying to improve that. And also, what we see is that there has been very limited ingress of automation into the industry. So that also leads at times to roadblocks, especially when larger projects are concerned. So what we need to do is we need to make it faster and less crowded. And also now in times of the coronavirus, where distancing becomes very very important, the materials or the way we construct needs to be much more faster in general. It needs to be distance. That means there has to be distance between the two people working. So that would mean using a bit more mechanization. Your construction needs to become much more efficient. You need skilled people to do that. That doesn't mean that a lot of labor would lose jobs, but rather we have to upgrade their skills, and then it would create much more efficient industry whereby which you would construct more, and with that we would again employ more. Lastly but not least, like in all the solutions that we are going to be covering, one thing I will not add again and again is that it makes all the construction chemical solutions definitely work towards increasing the durability and sustainability of the structures. So we have to build better and we have to build faster, and construction chemicals can help us do that. So to give you an idea, like a sneak peek on the solutions themselves, it goes everywhere from basic things like concrete and mortar additives to finishing aids. Finishing aids is something that help place concrete better. We look at waterproofing systems. There is flooring, then concrete repair and protection systems. There's tile fixing. There is like thing all architectural products are there. There are industrial products. They are just products for different segments in the industry. For heritage structures, for example, we do a lot of things in along that line. And then today, the modern or the emerging technologies in terms of resin-based systems, which are used for injection, for stopping water, and for soil and slope stabilization. So concrete and mortar additives, if we start off, it's like one of the biggest segments in the CC industry, and it really has shaped the way, or rather shaped the definition by which the construction chemicals go. So we have enabled things like self-compacting concrete, again, which concrete doesn't need a lot of working and a lot of labor to place it. Internally curing concrete, for example, to improve durability. Integral waterproof concrete. So lot of different ideas have come through. Like even improving properties of mortars and plasters, for example. Like these kind of plasters can be very very easily applied by a very very small crew. They can be sprayed. And for example, if you're using integral waterproofing additives, then you don't need to cure your membrane. So it really adds a lot of value, and of course improves the speed and ease of use of a lot of the materials. So among concreting and finishing is there are things like curing compounds, of course, which saves labor because it's a one-time application. The durability of structures, of course, is maintained, but it saves a lot of water that you might actually waste in curing. So it brings a lot of eco-friendliness to it. Then there are also other solutions such as plasters, for example, like you can see in the middle video just on. These are plasters that simply come out of a bag. You just mix it with water, place it into a pump, and you can simply spray apply it. Of course, you can do hand applied versions as well. Both are possible, but what this does is it really eases the use of the material and requires much lesser manpower and can be done much faster. The same goes for waterproof coatings. For example, you can do coatings that are spray applied, like in the leftmost video. In case you already have existing waterproofing problems, in that case also there are today special solutions available by which you can stop this water ingresses very very fast. So these are called modern injection systems. We'll talk a little bit about it later. I'll give you another few examples. And say also in protection of large long-term infra, a lot of the systems are very easily mechanizable. For example, here you can see like a team of about 4 people. These guys are doing a bridge deck, or are waterproofing a bridge deck, and they can pretty much, this team of four can finish almost close to about 2 to 3,000 square meters a day, which is tremendous output because of the mechanization and the type of materials used. The same goes for modern tile fixing materials. So these improve the pace of working as opposed to the old systems. They optimize manpower, so you don't need very large teams. The material comes in a bag. Simply mix it with water, and it's very fast to apply, easy to use. The sealers, of course, are again directly they come out for bucket. You simply roller them onto your marble or onto your substrate that you need to seal and protect. And the same goes for again grouts, which can be used for quick installation of machinery or quick installation of anchors or a lot of different things. So construction chemicals really makes a lot of these kind of systems possible. Then we can talk a little bit about concrete repair and flooring. So in this case, it has enabled concrete repair by completing repair in less steps. For example, if you see this last video, so you can now do concrete and save much more time because things like corrosion inhibition and bond coat is now combined into one material. For example, So you simply take this material that comes in a bag, mix it with water, you apply it in a first coat, it behaves as corrosion protection. Do it in a second coat, it functions like a bond coat. After that, you can easily finish it with a spray or a polymer concrete, which are very easy to work with. So you don't need to invest much time and effort in doing it. Again, liquid floor hardeners and concrete polishing are there, or we have also got resin-based flooring systems which can be applied manually or mechanically, and they really help to improve the performance of the floors in general. Concrete protection systems, of course, are applicable to a lot of different structures, be it heritage, be it industrial, be it residential, buildings, commercial, you name it. And a lot of these systems can be easily machine applied. They're very, very durable, last for over 10 to 15 years, and need minimal coating and minimal intervention. That means minimum maintenance. What that means is, again, that your construction can go through much faster. You are spending much less, so overall, your structures are much more sustainable. We also do a lot of there are a lot of modern systems available for heritage repair. For example, if you see dampness in your old structures or in masonry structures, then there are very simple chemical damp-proof courses available for those. Even if you want to repair structures, then we can use a simple cementary system. Like this is basically mortar that comes out of a bag. You simply mix it with water, and it gives you the exact same properties and behavior like a lime surkey mortar. Something that is very old, very historic, and this particular mortar is meant to mimic that. The only difference being it uses the same lime, it uses a similar material like surkey, but it is fortified with other material. So basically, you can spray this material, finish it properly, process it much more easier as opposed to the traditional materials. The same go for resin injection systems. So you can see that with that you can stop water. Like for example, on your left here, the first video, you can see water gushing in at almost 200, 300 liters per minute. And using this resin systems, you can stop it almost instantly. And all this is done using the small kind of machinery that you see in the last photo out here. So smaller machinery means lesser manpower. The solutions last pretty much forever, needs minimal manual intervention, and can also really take care of difficult problems. For example, in case of tunneling, where your tunnel is collapsing all the time. So you can use this injection resin system to kind of stabilize your entire tunnel, to facilitate the working to go much faster, and to have less problems in it, and also do it
Hello, everyone. I would like to talk to you. Hello, everyone.
Hello, friends. This is
I
Vivek
would like to
Naik.
talk to you
I'm past
about
president of Indian
having
Concrete
an
Institute
integrated
and
approach
managing director of Apple
towards
Chemie India
realizing
Private Limited.
construction projects.
Today, we are on the platform
Construction
of
projects have
India
many stages
Construction Week, which is
towards
organized by
their
CITC.
completion, starting
I
from
would
the
actually like to
conceptualization,
appreciate the
project
organizers and
preparation in
especially
terms
Dr.
of
Swaroop and
getting all
Dr.
the approvals, land acquisitions,
Bharadwaj
and so on,
for bringing out
then
these
the design
things to
engineering,
us and
the bidding
uh,
process, the
putting a
actual construction itself,
put
the
forward
finishing
a
operations,
step
commissioning,
in
and
new
finally the
technology.
operations and facilities part of
Now, I am
using
going
the
to talk
project.
to you on innovative
If one looks at the
materials.
overall life cycle cost of a project, the majority of cost comes after completing the project during the service life of the project. And if you look at the cost of the building or the project itself, the majority of cost goes towards the materials and the labor and equipment usage. So if you're able to optimize these two aspects, the materials and the labor and equipment usage, then we are able to optimize the cost and time. If one looks at the ability to control the cost of a project from the beginning of the project towards its completion, this ability keeps coming down as one go towards completion. The maximum potential for controlling the cost is there in the beginning and starts diminishing over time. So there is all the more incentive for us to take all the precautions right at the beginning to be able to control the time and cost for the concerned project. If you look at the various factors which govern a particular project, the functionality, of course, is the most important one. Then the bidding process, the design engineering, the actual construction method, the materials to be used, the plant and machinery to be used, and finally the project management to put together the project with all these ingredients. We need to have an approach towards integrating all these factors with the accent on the life cycle approach and then having overall innovativeness to get the maximum possible efficiency. If you look at the various ingredients for successful projects, typically, starting from the upfront clearances and using the right kind of design and construction method which are properly integrated, along with the right kind of materials, having adequate resources, and getting ensure the fronts availability at all the times, having a good project management approach with good risk management, and above all, a good project manager to put together all these ingredients and realizing the project successfully. In this process, we need to realize that design and construction method have to be kept hand in hand if one wants to realize a good efficiency. For example, for the metro projects, superstructure being done in many cities today, the precast segmental construction method is very appropriate in that it has the least disturbance to the traffic which is flowing all the time in crowded urban cities. So here again, we are sure that the construction method and the design method are very closely interlinked and have to be taken together. And particularly for indeterminate structures, the two are very closely intertwined and we can't the other. And developing good construction methods calls for expertise in many areas like construction methods, equipment, how to get the best out of equipment, and above all, a good innovative out of the box thinking to ensure that we have the best of methods to suit the given context. Construction is an important activity which is not normally realized commonly. It covers enablers engineering, for example, farm work, temporary structures, site layout. For example, a good site layout can facilitate very efficient movements inside the site and facilitate cost control and minimizing wastage. Then, of course, the designing the methods, construction methods for doing the work, and then deciding the right kind of equipment and to get the best out of the equipment, being used, and above all, having good constructability in the designs to ensure that we are able to do the construction easily with the best of quality and safety. So construction engineering is sometimes neglected, but that's of great importance. Today's construction is highly mechanized, very highly automated, with a lot many equipment for the various operations. So we need to choose the appropriate equipment, particularly since the equipment are costly in the Indian context. And having got the costlier equipment, we need to make sure that we get the best out of them during the construction. Making sure that we get the best of productivity for its operation, is used for the maximum possible time without much downtime and so on. So equipment, get the right kind of equipment and use it properly. The contracting or bidding out process is again a very important stage or step in realizing the projects. Today we have many examples of the EPC, the engineering, procurement and construction, or a simpler design and build method to get good bids. Here, all the engineering and construction integration is done by the constructor to suit his own capacity and capabilities and to suit his experience very advantageously to get an integrated project, which often will have the least cost because it is highly efficient. The owner can get a slew of solutions instead of only one bid, one solution to get the maximum efficiency and functionality, very competitive. And then we also have a lump sum. We also have lump sum bids with ceiling on the cost. So there is not much possibility of cost overruns. And again, the right kind of materials, for example, using self-compacting concrete when there is reinforcement congestion and so on. All the aspects are properly integrated in this kind of bid. Coming to the final aspect of construction management, there have been many methods evolving over a period of time. And today we have a very new good paradigm called lean construction management. In any typical site, there are many players, many theaters of operation, many coordination points. With all this, there are a lot of delays and high unpredictability and high uncertainty. Construction is notorious all over the world for high stress levels and various kinds of problems. Now, lean construction is able to address all these problems quite effectively. Lean actually is a concept or a culture and a way of doing things. But of course, lean also has many tools which are used for improving the efficiency, cutting down wastage and so on. The main concept in lean is to maximize the client value and minimize or eliminate wastage. We want to look at the project as a production system, as you would look in a manufacturing environment. and the focus is on the flow of the entire project. And all the time we keep looking for continuous improvement, making things do to be done more efficiently, and collaborative working involving all the people at the site. So Lean has many dimensions, and today we have a large number of projects, not only all over the world, but also in India, where we are able to realize substantial benefits by practicing Lean construction methods. Today we have a lot of IT applications in civil engineering. For example, BIM, Building Information Modeling. And going much beyond BIM, today we have an accent on digitalization of the entire construction. We have aspects, we have processes like virtual reality, augmented reality, IoT, and so on. So we need to get modern with the modern new technologies to get the best out of construction. And finally, to look at what a typical project manager does. He has many dimensions to take care of in project management, starting right from project preparation, your bidding out process, then the design, planning, getting the best construction methods, integrating your construction equipment and the materials, taking care of all the people at the site, the finances, and of course the standard quality and safety, and managing the clients and so on. So there are so many dimensions to be managed by a good project manager. And I would say that a good project manager is much more capable than a typical manager in the manufacturing environment. The complexities, the different dimensions, they are all, substantially vast for a typical construction project. And a good project manager is definitely worth his weight in gold. So concluding, the concept of integrated engineering, starting right from the functional conceptualizing and going towards the design, the construction methods, and finally the operations, we need to have the integrated approach to get the best out of projects. Of course, we need to involve the best of experts in the various stages. R&D from research institutions or academia is also very important to get the best of materials and then the designs and the construction methods. So overall, the integrated project paves way towards getting maximum efficiency and very good control in time and cost towards realizing projects. Thank you. Good day. Stop.
Managing Director of Apple Chemie India Private Limited. Today, we are on the platform of India Construction Week, which is organized by CIDC. I would actually like to appreciate the organizers and especially Dr. Swaroop and Dr. Bharadwaj for bringing out these things to us and putting a put forward a step in new technology. Now, I am going to talk to you on innovative materials for sustainable construction. I'll be speaking on innovations and sustainable construction. If you are talking about innovations, successful commercialization of a product, process, or services as a part of demand of the market or a target customer is referred to as innovation. As far as civil engineering industry or construction industry is concerned, the definition is a little different. Let us look at what is sustainability and what is the innovations. I am giving you very simple examples. Recently, in the Discovery Channel, there was a sustainability appreciated, and wherein in Rajasthan, refrigerators were made out of clay. And in this refrigerator, except making ice creams, everything can be made, everything can be used. You can put fruits, milk, vegetables, and keep it cool. And there is no energy required, external energy required. And the refrigerator can cost as less as around 2,000 Indian rupees. And it's absolutely sustainable, and it has been appreciated all over the world. Similarly, if you're talking on the innovation side of it, I really have one example, which is of Tata Nano. Now, this particular vehicle has got innovations of 31 in the design part, 31, and around 37 patents on the technological front. So this is something great. Now let us look at what our construction industry has done on the innovation side. Yes, recently there is a huge mechanization, concrete mixers, cranes, power tools, they have come in a big way, computer-aided design, beam modeling system, modular construction, which is precast, prefab, and also robotic plotter stations. So this has changed the way we do the construction. Similarly, if you are looking at the pavements, concrete roads are being done everywhere in the world, and even there are precast, prefabricated concrete road panels. And the innovative part is that now people are even trying to put sensors in the lifting holes, and then there will be sensors, processors, which can transfer the information about the behavior of the concrete pavement. You can monitor it sitting in the office, and that is something great. If you are looking at the innovations on the resource side, yes, manpower, we are taking care of great. We are having smart clothing for the people who are at the site. This clothing can change its own temperature based upon the body temperature of a worker. And for the safety side also, if you are putting these new gloves, which are developed recently in Germany, then the gloves will change its color if the person is touching his hand to any toxic product. So this is quite a safety parameter, I will say. On the site resources, smart and safety glasses have come. Construction drones, in my opinion, is a big innovation, especially for the construction people, where you can monitor large stretches of road or canal lining or remote places very comfortably. So also multi-storied buildings, you can reach in every nook and corner and find out the status of it and understand what is going on at the site. So, and it is coupled with productivity software. So this makes a solid bag. On the material front, as far as the innovations are concerned, many things are coming up. To name few, you can see the screen, translucent wood cooling system with bricks, Martin concrete, biological product furniture, floating piers, even self-healing concrete. Well, in my opinion, self-healing concrete has already come into the market with a big bang, and there are a lot of advantages of it. If you see the basic construction chemicals, which we started using in 1962, construction admixtures, they were developed by Dr. Hirata, Hattori, and Ansberg. And these products were initially not meant for construction industry; they were for leather industry. But we found that SNF and SMF, sulfonated naphthalene formaldehyde and sulfonated melamine formaldehyde, can very well be adopted in the construction industry as superplasticizers, and we started using it. These developments took place, and thereafter, the actual development which has come, especially for the construction industry, in the field of admixture, is done by a young Japanese scientist, uh, Dr. Hirata. He developed a different molecule of PCE. He reacted MPEG with methyl methacrylate or acrylic acid, and he developed a molecule of PCE, which is polycarboxylate ether. And PCE has been changing the entire construction technology in a big, big way. With PCE in hand, now we construction engineers can have a concrete pour of 10 meter at a stretch with congested reinforcement. You can have big raft or mass concrete work of 2 meter thick also on a large scale without any hesitation. There cannot be any cold joints also. We can have free flow concrete, high strength concrete. Many, many farms have come up. But basically, it is because of PCE. The further development in the PCE technology is a viscoflux technology. Well, I'm very proud to be a part of viscoflux technology because this is a green technology. How green? Because basic PCE technology aims at producing a product by heating it up to 160 degrees centigrade in the first phase of reaction, and in the secondary reaction another 120 degrees centigrade is heated, then cooled, and the process takes around 10 hours. In PCE technology, what you can see on the reactor on the right hand side, it is only one process. It is almost at the room temperature, no heating, no cooling is required, and the process is complete in 2 hours. So that's a great innovation. Similarly, there are innovations in the other products in the construction side, which is curing compounds. Curing compounds have changed huge amount of water. The water which we are using can be reduced to very, very large extent. They are of wax base, water base, or aluminized resin base. And once you put a curing compound, then the evaporation control losses, and there can be good protection, and water for the curing can be totally saved. Well, talking about the evaporation control, there is recently a new development. A product has come which is evaporation control agent. Now, this evaporation control agent is a liquid which you can spray immediately after the casting is done on the pavement. So the evaporation controls takes place, and thereafter you can put curing compound and then take care of the pavement things. Well, this is what I have shown in the picture, that in the first slide you can see the evaporation control agent put, and thereafter, after half an hour or so, when the concrete can retain its texture, and you can put do the brooming, texturing, and curing compound. Well, as far as the RCC is concerned, bipolar corrosion inhibitors are one more great product, that the concrete which is embedded, the steel which is embedded in concrete will not rust, and, and this is a big benefit for the construction. Recently, there are developments in the sealants. White toppings are being done in many parts of India, and for the filling of the joints of these white toppings or tunnel joints or concrete roads, sealants and adhesives with polymer or polysulfide or polyurethane have come in a big way. As far as the construction speed is concerned, there has been innovation that you can have the segment bonded adhesives, what you can see in the lower picture. You can do the precasting at one place, bring the segments at one place at the site, and go ahead with joining of the various pieces and do the post tensioning, and your spans are done with. Similarly, you can do construction over sea or over a river span, or even congested traffic in the city, by having post tensioning method at the top, as what you can see in the picture. This is what I was telling you, that these are the places where segment bonding adhesives have been used, and this is applied on the surface of the segment, and then you put the two segments together. As far as the durability is concerned, yes, carbonation is one process which leads to the disintegration of concrete, and there are carbonation protection coatings which can be used for tunnels, flyovers, and even for the steel structures, there are new protection coatings. Now, this crystalline durability admixture, this, in my opinion, is a game changer, because this product, when you add into the concrete, it can bridge the cracks and the fractures in the concrete even up to 0.5 mm thickness. And this crack bridging process takes like a self-healing, and that is why sometimes it is called as self-healing concrete also. And what you can see on your screen is a laboratory example of how the self-healing takes in around 30 days. Now, coming to the sustainability part of it. See, if you see overall construction industry, 40% of the global energy is consumed by us. We are also responsible for 40% of the waste generation. Not only that, we are producing 50% of the carbon dioxide emission. So we are not very green or very environment friendly institute, this industry, I can say. What we will have to use, that if we want to be sustainable and good industry, we will have to use all the innovations. We will have to use supplementary cementitious materials like fly ash, microsilica, industrial waste. And not only that, once we make a nice concrete mix design out of it, with the help of PCEs, then obviously with better concrete technology, you get durable concrete because there is a longer span, and the longer span will again give you sustainability. So whatever we have talked about the innovations, now if we put it into the field, we will be achieving better and better sustainability. What we have to do is we will have to forget the old technologies of admixtures, that lignosulfonate, SNF, SMF. These were red technologies in my opinion. What is green is polycarboxylate ether and viscoflux technology, which is going to give a lot of benefits. So also, once the structure is done with, we can have some of the new products which have come is foam concrete and albedo paints, which will give you a very sustainable structure. This is what the foam concrete is this. And similarly, for the cool roof, for reflecting heat and keeping the roof cool, these cool roof products are used, and they help to drop the temperature to the tune of 10 degrees centigrade. And this is one good example, in my opinion, of a sustainable construction or a sustainable product. We can definitely replace the conventional plaster by activated carbon or charcoal plus industrial waste or crushed sand, and make plaster out of it. And this has been tried, and people are now coming with it. So this will save a lot of natural resources. There is one more new development which I would like to discuss here, is a geopolymer, wherein you are using fly ash, silica film, sodium silicate, metachlorine, and GGPS on one side. On the activation side, you have alkalis, which are NaOH or KOH. Gravel sand, of course, it is used. There is no cement what is used. Once you make this product, the product is really wonderful. It has got a lot of advantages. It is quite light, and it is resistant to pollution, and it is equally strong as conventional concrete. Recently, there are some examples where underground metro tunnel sections have been done in geopolymer concrete with fiber reinforcement in it. Coming towards the end, recently what I found that Israel has developed some protection coatings which will prevent the spread of corona. That's really very good. And these protection coatings can be used in the factories, public buildings, airports, hospitals, and stores. So this is what we wanted, and this has come. So to close up the thing, What I feel, friends, that the things have changed in the world, and what positive thing Corona has brought is the world has changed and there is a will to act together. And once we use all these sustainable technologies and sustainable products, whatever I have narrated, we can make sustainable future. So let's leave a legacy of sustainability for the future generations. With that, I would like to close. Thank you, organizers. And now I can take up the questions. Thank you.
This question to the forum: is 3D printing of concrete an option? Now, concrete 3D printing is a subject of much study all across the world. And in IIT, we have formed a team called Imprint, which is basically composed of IIT Madras, faculty and students of IIT Madras on one side, and also a startup company called Twasta Manufacturing Solutions, which is a specialist company that deals with manufacturing printers for 3D printing. Okay. So I'm very happy to bring this subject onto the India Construction Week. And I'm Manu Santhanam, currently the professor and head of Department of Civil Engineering at IIT Madras. So of course, you all are aware of 3D printing, that it's actually one of the additive manufacturing techniques. So as opposed to subtractive manufacturing, where we typically have a much larger object and we cut down parts from that object to make it of the desired shape, in additive manufacturing, we basically deposit material layer by layer to create the object. Okay. In construction 3D printing, this relates to concrete, which is being poured layer by layer and then built up to the required shape without the need for formwork. In construction, generally extrusion based 3D printing is extensively used, and that can be done with either the help of a frame based system like what is shown here. You see a frame based system where you have a gantry basically carrying the nozzle across a frame which is controlling its movement in the X and Y directions, and the nozzle itself can actually move up and down the shaft in the Z direction. You can also have a robotic arm system where you have a centralized robot which can access different locations within the job site and deposit concrete where it's needed. There's another technology called binder jetting, which is very interesting from the perspective of actually bringing out uniquely shaped structures. However, its application to actual construction projects is rather limited. For the most part, we're dealing with extrusion-based 3D printing across the world. What are the advantages now of extrusion-based additive manufacturing? Of course, reduction in construction time and labor cost could be one major advantage, because we don't need as much labor around, right? And construction time can be reduced significantly because this technology does not need any formwork. As we all know, formwork, assembly and disassembly probably needs about 60% of the time that is spent in concrete construction projects. Further, it also saves on about 30 to 40% of the costs associated with the formwork. The other major advantage of having a 3D printed structure is that you have geometric and design flexibility, and which makes it possible quite easily to produce complicated shapes which are otherwise not conceivable with usual formwork based construction. So it's very good for architectural elements and can provide very interesting perspectives on how construction can be accomplished in difficult terrains. There are several companies around the world which are engaged in 3D printing. Some of the common ones, popular ones, are captured here in the slide. There's also an example that I've provided here from the company called Winson in China, which prefabricates 3D printed components in a centralized plant or centralized factory, brings them to site and assembles them to produce a structure. You can speed up construction significantly in this way. You can see here in this top box, you see the printing being done to prefabricate such construction elements, which are then stacked in the factory and cured, because the curing has to be done to have concrete realize its ultimate strength. And then these are transported to site and then placed with the help of cranes and other loading equipment, right? So this becomes a fairly easy method of construction. The question always arises, how is it any different from precast construction? The difference obviously is in the fact that in precast you need formwork. Here you don't need formwork. You can actually print the concrete exactly in those locations where it is needed. Okay, and it acquires its shape does not need a formwork for its shape. 3D printing has been accomplished for several demonstration projects across the world. People have used it for houses. For example, the one on the left here was an on-site constructed house in Moscow by this company called Apis-Cor. And you can see this robotic printer that is delivering the concrete in the required location. There are also several examples of construction by this Vinson Global, and it turns out they also have a record of printing components for 10 houses in a single day. So you can actually almost have a factory made house very quickly delivered to the site where you want to actually assemble it. There are other examples, of course. This is a very common one that you come across when you actually do a search on Google for 3D printing of concrete. This concrete castle by Rudenko is a very common example that you see there. There are several instances where people have actually experimented with what 3D printing can do in terms of producing complicated shapes for houses. There are also other shapes, for example, this very interesting shape that has been produced by Vinci Construction in 3D printing. There are very interesting looking furniture elements that have been done by 3D printing, and of course here there's a Vinson Global is actually done. This bus shelter which was printed of course in this direction here and then tilted by 90 degrees to produce the bus shelter. Okay, these are several examples. There are also some infrastructure based constructions which I'll come to in just a minute. There's some more examples of buildings. So here this is the army barracks done by the US Army Corps of Engineers using 3D printing. This is the only demonstration structure in the world that is using aggregate in it. Most other 3D printed structures use only mortar, not really concrete as such. Very interesting design produced by 3D printing by Siam Cement Company in Thailand. And you can see the intricacies involved in actually getting these sorts of columns together. And this is actually an experimental fabrication done at the ETH University in Zurich. As I said, some infrastructure components have also been printed using 3D printing. So this is actually a bridge, pedestrian bridge that has been printed in Madrid in Spain. And this is actually a post-tension segmental girder which has been printed in Netherlands. So you can see that these are the printed components and they have been later post-tensioned and then carried to site and placed as a single deck. Now, what are the challenges that are involved in 3D printing of concrete? First and foremost is that we need to do a good quality mixture design which is robust and produces stable mixtures which can be used for printing. The other aspect is incorporation of coarse aggregates in the printing mixture, and that's something which not many people have been able to do because coarse aggregates present a major challenge. And third is actually how do we actually reinforce printable concrete, because it's not possible to print the reinforcement alongside the concrete. How do we do that? Okay, so that's something which is our challenge. In terms of modeling, of course, we want to understand how this material behaves in the early stages, because we know that we are going to be putting it layer by layer, right? But we can't obviously wait for the layer below to get completely solidified before we put the next layer. We want the structure to be still green or fresh while the next layers are getting poured. And that's because we want to have these layers bonded well together. If we wait too long, it's not going to bond well. So how does it behave in the fresh state? How does the internal structure build up with time? And that's something which we need to understand how to build up structures fast while printing very quickly. Okay, and of course, several different types of printers can be used, and each produces its own effect with respect to the delivery of the material. How do we incorporate that in the modeling process? Thirdly, when we actually produce these elements which are going to be used in a building or other structures, what kind of tests do we devise to study whether these are adequate in terms of load carrying abilities, both in plane and lateral loading? Okay, so that is something that we need to devise methodologies for, because these are not standard methods that can be used for 3D printed components. And what effect does this layering have on the overall capacity is something that also needs to be studied properly. Now, as far as Imprint is concerned, that is the collaboration between IIT Madras and Twasta, we have come through a long process. We started off with a very small printer, which we call as Testbed Printer 1. So here the objective of our studies was to develop a systematic procedure for mixture design of 3D printable concrete, and then devise or adapt very clearly the test methods that can be used to define how the mix extrudes through the nozzle, how it actually builds up layer by layer, and how it actually behaves later in terms of its retention of workability and what influence do other additives have on the system. Then we moved on to a slightly larger printer, but still it was an experimental printer, research printer, and there we actually printed modules which were assembled to make a small room type structure. Third, we moved on to a much larger printer which was able to print up to about 1.5 meters in one go, and with this we printed a toilet structure in 2 modules. And this same printer is now being used to create wall elements which are 3D printed and are being assembled to produce the first 3D printed house that we may have in our country, that is going to be unveiled very soon. It's not yet ready. So this is the example of the testbed printer, fairly simple. All it has is a gantry which is very small. Okay, you can see that this is a gantry, and you have your movable arm which is moving around on this gantry, and the nozzle attached to the movable arm. With this nozzle we have printed square elements like this, also wall elements which are having different layers. What you are able to clearly see is that each layer has a perfect thickness. That means the layer below has not got compressed because of the weight of the layers above, and that's because of a proper design of the material itself. Okay. Mechanical characterization can be tricky because you obviously can't really mold this material and then test it. So you have to test the strength of the material in the layered fashion itself. You can test the strength with respect to flexure, with respect to compression as a wallet for instance, or you also have to test the strength of the interface between layers, and that can be done by actually coring and then slicing or shearing the material across the layer. And that layer was seen to or the layered specimens were seen to have about 10 to 15% lower strength than compacted molded specimens. So that means that the layering does have an effect on the load carrying ability of these materials. How much of an effect? It's only about 10 to 15%, so that can be designed for without any difficulty. So the testbed printer 2, which I said was still a research based printer, was used to print these sorts of modules, and these modules were then stacked together to form a larger room shaped structure. The one difference here was that the mechanism of delivering the concrete was through a pump. So we are actually pushing the concrete, the advantage being that we can now start pushing very stiff concretes through the nozzle, and stiffer concretes are better from the view of buildability. They can build up quite nicely. Problem is the pressure that you apply may cause a phase separation of the liquid from the solid, and that is something that you need to accommodate for by choosing the right type of testing mechanisms to ensure that you don't cause this phase separation. So these are the modules that are getting printed in this picture. As you can see, this is the nozzle, this is the pipe carrying the concrete to the nozzle, and nozzle is basically printing it. And this was the modular structure that was constructed with the help of this kind of a printer. As you can see, the modules are approximately about 30 centimeter height. Each module had about 20 layers of 15 millimeters that caused about 30 centimeter height for each module. And between each layer, we had a mortar placed to ensure that we get good bonding between the modules. Okay, and in each mortar layer, we also placed some textile reinforcement to ensure that we got some additional strength in those layers. So this was a modular structure which was inaugurated by a representative from the Ministry of Housing and Urban Affairs. We also conducted a workshop after this and where we actually disseminated this technology. This workshop was sponsored by the Ministry of Housing and Urban Affairs, and the Honorable Secretary of this ministry also came down to inaugurate our 3D printing workshop. Now with this research-based printer, we also printed several furniture elements. You can see the kind of shapes that can be printed. Very interesting table bottom. You can see here very interesting chair, garden furniture essentially being printed with these with this research-based printer. And you can also have the ability of printing complicated shapes. This can give rise to structures which we have lost the use of today because we don't have the workmen to make the nice jalis that were characteristic of many of our old buildings. With 3D printing, we can start thinking of doing the same. In stage 3, of course, as I said, we moved to a larger printer and we printed much bigger module. We printed the toilet module and this is actually the upper half of the toilet module where we printed the entire walls and also the roof completely with the 3D printed material. Okay, so this is the roof printing in progress, and this is the finalized upper half of the toilet module. We've gone through several stages of research in 3D printing, and several papers have come out as a result of this. One paper that I'd like to draw your attention to is this recent one in Indian Concrete Journal, which you should look at if you're interested in construction 3D printing, because it brings about a good overview of what has happened across the world and in India with respect to this technology. So, to conclude, 3D printing is certainly a highly promising technology for the future. We have undertaken systematic research at IIT Madras, which is under the Imprint banner, basically composing of IIT Madras and Twasta, which has led to the development of a robust mixed design procedure that can be applied depending upon different types of the printers that are available for printing. So we also were able to produce India's first 3D printed structure, which was modular, and we are also on the verge of creating more exciting structures which will have a good repercussion on the concrete industry as a whole. So I would finally like to say the key takeaways: IIT Madras definitely can provide support for development of printable mixtures because we have an expertise in material technology. On the other hand, as far as the printing is concerned, you have Twasta Manufacturing Solutions, possibly the only manufacturer in India that can actually make 3D printers for construction 3D printing. So you can visit their site, twastagroup.in, to get in touch with them and also custom make printers for yourself to do 3D printing. So thank you all very much. You can reach me by email for more questions, manus@civil.iit.ac.in. I'd like to acknowledge the contribution of my PhD students, Rahul and Shantanu, as well as the entire team of Twasta, not just for providing the pictures, but also for this very fruitful academic industrial collaboration that we have had over the last 4 years now.
I will be sharing with you today a presentation on BIM, which is Building Information Modeling, and its relevance to construction industry and construction companies, more so, especially with its importance in the world as we go forward, and with reference to COVID and sustainability. The presentation has been prepared along with my colleague Ashit, and he is the technical expert here, and I hope he will be able to attend part of this conference as he had not been keeping well. And I will just begin to share the presentation. Give me a moment. So here we're going to look at building information modeling with special reference to construction industry and construction companies. So let us look at what are some of the core issues that are typically faced by construction companies and which may even be highlighted further in this post-COVID era. There will be fewer jobs in the market, increasing number of agencies bidding for the same projects. It would be important to quote at lower margins or more effective quotes rather than lose the project. There are typically in projects project delays which happen due to miscoordinated drawings, and that makes you lose time and money, and perhaps the client's trust as well. There is bad cash flow and inventory management and loss of profitability. There is high volume of wastage. So if all of these can be more efficient, the entire industry would be more efficient and not just increase bottom lines, but also would work towards sustainable development because it would be utilizing fewer resources. So inaccurate estimates is another area which is one of the main causes and which causes wastage and time delays. There would be lower profit bid. Then construction delays typically are called inaccurate cash flow estimates, and then there are delays in procurement. There would be miscoordinated drawings. Very important aspect is clash between different building elements, and we all know how much everybody has to be so present at the site. It involves major site involvement, trying to resolve these clashes at site. So BIM is a solution that helps to achieve greater efficiency and also improves bottom line. It creates for very accurate and verifiable quantity takeoffs, if, of course, with the caveat that if the BIM model is well prepared and well coordinated. You get the most accurate estimates. It provides opportunity for lowest possible bids. It provides for accurately planned cash flows. There's early detection and resolution of clashes at the pre-construction stage itself. And all of this would go for a better project, a better client confidence, and improved bottom lines. So what is BIM? BIM, or Building Information Modeling, is a process for creating and managing information and on a construction project across the entire project life cycle. One of the key outputs of this process is the building information model. That is a digital description of every aspect of the built asset. So this model draws on information assembled collaboratively between the designers, architects, engineers, MEP consultants, all of the role players. And this is updated at key stages of a project. So typically we can say that BIM is an intelligent 3D model process that integrates people, data, and technology to optimize building design, construction, and operations. So what is the kind of information that goes on to the model? So a BIM object is a combination of many things. Product properties such as the thermal performance, could be the structural capacity, the geometry representation of the product's physical characteristics, visualizing data, giving the object a very recognizable shape. Then there's functional data such as dissection zones that enable the object to be positioned, and it will behave in the same manner as the building itself. So it's an entire simulation of the building. And also further, various plugins integrate several other outputs which you can generate from BIM models. There can be specifications, operating schedules, all of those input outputs can be obtained from BIM modeling. So these are intelligent 3D models, unlike the presentation 3D models. So this is real life building elements such as walls, floors, doors, ducts, pipes, etc. used to build the model on a computer. A multidisciplinary model is used to detect clashes between the elements. That means all the MEP, structure, architectural elements are already pre-designed and seen, visualized in a three-dimensional model and resolved, even before the start of construction on site. The building elements in the 3D model have dimensional and physical properties that can be quantified and extracted. That means each element can have, let us say, if it has a thermal properties, then we can see the behavior of the entire building in response to the different climate. We can see its total energy consumptions. All these may, of course, require certain plugins. Here's an example how it works in terms of coordination and clash detection between architecture, structure, and MEP. So in BIM, typically there are LODs or level of development. And therefore a BIM model can be made to different level of detail. The basic level of detail at initial stages from LOD 100 to 300 is typically used by designers such as architects, engineers. And LOD 300 to 400 is more applicable for the construction agencies themselves. And the LOD 500 then is as built and highly detailed and also used by facility managers for even managing their facility schedules. Here are just some examples just to familiarize what LOD 100 would be like. That represents basic massing and quantification of spaces. It is used by designers at the preliminary conceptual phase. Then at LOD 200 is also used by designers, and these are spaces are modeled within bounding elements. So elements start getting defined as walls and columns, and the quantification of perimeters and spaces happens at this stage. And LOD 300 typically is used by construction agencies. The wall veneers are modeled as separate elements. The walls are modeled to actual dimensions. And even the penetrations are modeled to nominal thickness. And the quantification of individual materials is possible at this stage. And LOD 350 is typically used by designers and construction agencies, and it would start involving the level of, let us say, GFC drawings. So wall framings are modeled, the support structures would be modeled, all penetrations are modeled. And in this example, we can see the elements that are in red. So those would get defined and then they cannot be cut easily for coordination with MEP elements. Then LOD 400 is typically used by construction agencies. The entire wall framing is modeled to support the fabrication. So at this stage, the fabrication details, outputs, elements, materials, quantification could be obtained easily. Connecting elements are modeled and includes, but not limited to, fasteners, clips, other hardware. And detailed quantification, of course, will include up to the extent of the fasteners, etc. required. So what are the benefits of BIM? Of course, BIM itself is a highly detailed topic, and it's people would, anybody interested would obviously take it further, which we can discuss or Ashit could discuss. But BIM basically brings together all of the information about every component of a building in one place. It makes it possible for anyone to access that information for any purpose. So that single model could also be shared. And it helps to integrate different aspects of the design more effectively. In this way, the risk of mistakes or discrepancies is reduced and abortive costs are minimized. BIM data can also be used to illustrate the entire building life cycle from cradle to grave, from inception to design, and to demolition, and including materials reuse, spaces, systems, products, and sequences can be shown in relative scale to each other and in turn relative to the entire project. So we can see what high level of efficiency can be there, and here we can begin to see the link with sustainability. And by signaling conflict detection, BIM prevents errors creeping in at the various stages of development or construction. So let's look at BIM and sustainable construction. So sustainable construction in the Lafarge Holcim Foundation article is defined as that sustainable construction involves issues such as the design and management of buildings, materials performance, construction technology and processes, energy and resource efficiency in the building. In his article, David Bursek in constructabletrimble.com states that there are three main connections between BIM and sustainable construction. The first is greater transparency during the design phase. Second is the greater efficiency during design and construction phases. And third is greater control during the operations phase. How BIM offers greater efficiency during the design and construction phases. The BIM 3D virtual prototypes can be easily shared and used for real-time collaboration and simulation to test the logic and sequence of construction. From estimate and takeoff to layout and ongoing project management, every step in the design and construction workflow is reviewed and enhanced to the extent that BIM technology is integrated. These improvements can be seen in speed of job completion, the efficiency and cost saving that come from prefabrication, a reduction in errors and ad hoc troubleshooting, a reduction in crew redundancy, and an improvement in asset management. What about BIM in the COVID era? So here I quote from an article in World Economic Forum by Fan Yulin, saying, here's how smart construction could transform home building after COVID-19. He states, the construction sector is already using building information modeling. During the COVID-19 lockdown, BIM was more widely adopted in the industry. It enabled projects to continue in a digital and virtual environment, even when the participants were unable to meet in person. This collaborative approach allows data to be shared across professional disciplines and businesses and facilitates smarter construction. Especially in the prefab industry, the data can be fed into manufacturing processes for components and modules that are later put together to form finishing buildings. The same article goes on to state that the future of the construction industry is digital, and BIM is the future of design and long-term facility management. It is driven by technology and clear processes, and it is implementing change across all industries. As hardware, software, and cloud applications herald greater capability to handle increasing amounts of raw data and information, use of BIM will become even more pronounced than it is in current projects. And that is really the way forward for us to make concerted and renewed efforts to really incorporate BIM and promote BIM in our various construction industries, in our processes, in our design stages. And I think with that, on that note, I would leave and say thank you. And I also thank Ashit for creating this. So thank you all.